Before we begin, let me introduce you to the process of interacting with us during the course of the webinar. At any point of time in the session, if you are facing a technical difficulty or you have a doubt related to the content of the session, please feel free to send it to us through the chat window, which you'll be seeing on the right of your screen right now. Our team will be glad to resolve these problems or to answer your doubts. In order to maximize your webcast experience and have a learning experience free of glitches, we are offering you two audio options. You see the presentation on the screen. You can choose to listen to us through VoIP or Voice over Internet Protocol. This means you receive the audio at your end through your computer speakers. Adjust the volume of the speakers for a better listening experience. If you're on a slower internet connection, you might experience a certain audio lag or broken audio reception. In this case, we recommend that you listen to us using our toll-free number. You can dial this number from your mobile phone or your telephone free of cost, and you will start receiving the audio from your telephone line. The numbers for attendees in India is 1800-425-4061, followed by the PIN 507-248#. For attendees outside India, it is +91 44 2370 2370, followed by the PIN 507-248#. In this week's edition of Webcast Wednesday, this is me, Rishi Iyer, an applications engineer with National Instruments, and we'll be talking about NI TestStand and how we can use it to improve our testing experience or automation of testing. Last week on Webcast Wednesday, my colleague Jagrati took us through some glimpses of the CLAD exam, and we also sat and solved some CLAD questions, which I hope proved very insightful and useful to all of us here. So today we'll talk about NI TestStand. We'll just do a very brief introduction in case we are interested in doing more features. Then we will continue this through the series this year. What is NI TestStand? NI TestStand is an industry standard test management software developed by National Instruments. It is used to develop and deploy automated test and validation systems much faster. In case you want to check it out, I would recommend that you download the evaluation version from www.ni.com/teststand/download. The agenda for today, we'll look at what is a test management software and where can we use NI TestStand. Secondly, we'll look at a few features inside NI TestStand, and we'll get used to the interface and get comfortable with different terminology that we use in TestStand. And finally, we'll look at how do we interface LabVIEW and TestStand to work National Instruments software products. Just to give you a very brief introduction about TestStand, TestStand has two different versions. One is a development version, one is a deployment version. So when you develop a code on TestStand, you use various user interfaces and tools to build test sequences and code modules. You use this by interacting and calling APIs from the TestStand engine and certain drivers to interact with hardware. All this together makes your test sequence or test program, which you packet in different versions, let's say version 1, 1.1, 1.2, and deploy onto multiple test systems. In the multiple test systems, the operator can operate it in the deployment mode, the code, and in which case he can either be exposed to the code that you have written, or he can be completely independent of it, just running it as an operator. We'll look at that a little later. So when it comes to what is a test management software and what is the role of a test management software, we see that for any test system, we have two different parts I would call it. One would be a test program and one would be a test framework. So the framework is a set of operations which are repeated for each product tested. So let's say today I'm testing a mobile phone and tomorrow I'm testing a GPS receiver. Irrespective of these two different devices, if there are certain operations, that I perform which are the same for both these products, then that would fall under the purview of my test framework. If there are certain operations which are different for both of these products or for any product tested on the test system, then then that would be a component of the test program. For example, let's say I'm using a test program and I'm testing a mobile device. I need to press the start test button, the stop test button, and I need to get a display whether the test passed or failed. So in this case, irrespective of whether it was a mobile phone or a GPS receiver, I would still have to press the run button, press the stop button, and get a pass or fail result. So something like this, that is a user interface, would be something that falls under the purview of my framework. Similarly, user management, different administrative levels, different operator levels, tracking of different unit under tests, test flow control, and report generation and result archival are some things that form under the purview of a framework, in which case, irrespective of which product I am testing, I would require these things. A test program, on the other hand, performs operations like calibration, data acquisition, instrument configuration, measurements, result analysis, test strategy, which would be different for different products. So how does a test management software help us? A test management software helps us by allowing us to reuse these code modules efficiently without any redundant code development. And secondly, it develops and provides you a modular test framework for the operations that repeat for each product. So just to test our basics, what is a test framework? A test framework would be something that has operations which are related to each and every product that are to be tested on the test machine or test system. A test program is specific to a particular product. But then you can say, I can do each of these operations. If I look at the previous slide, calibration, instrument configuration, data acquisition, all of this can be done on LabVIEW. Why would I shift and migrate to a completely new platform, or why would I want to do this to a completely new environment? So LabVIEW is something that we call in TestStand. So yes, we can do all of this in LabVIEW. In fact, a lot of times we do all of this in LabVIEW and implement it on TestStand. But secondly, what it allows us to do is automate the process of testing multiple UUTs. So whereas it would take me a lot of time to build a certain framework for generic products on LabVIEW, TestStand offers me some of these frameworks where I do not need to build anything from scratch. So I can build my code, my actual testing code on LabVIEW, but whereas I do not need to worry about report generation and other multiple things that fall under the purview of the framework, because TestStand provides me that. However, TestStand also provides me the customization, the ability to customize my framework itself. Again, TestStand is not necessary that you only need to use it with LabVIEW. TestStand is code agnostic or language agnostic. We can use it with LabVIEW, LabWindows CBI, C++ DLLs, .NET, ActiveX, HTBasic. So I can have testing modules in any of these languages, and I can call it in TestStand to test particular parts of my UUT. So let's just talk a little bit about TestStand. So if I just open up my TestStand interface, this is what my TestStand interface looks like as soon as I open it up. So this is sequence file 1, as you can see here, is the name of the sequence file that is open. So just like we have .vi's in LabVIEW, the sequence file is one particular independent file. Within the sequence file, I can run multiple sequences. So let us say that this is the main sequence, which is the default first sequence of my sequence file 1. I could also insert another sequence, and let's say I call it first. So this would be another sequence, and I insert another one and I call it second. This is a third sequence. So these are different sequences within the same sequence file. A different sequence file would look like this, wherein the sequences would not be the same as in sequence file 1. Excuse me. So within main sequence, I can see the steps of main sequence detailed over here. So within this sequence, I can put in multiple steps. These steps will execute in a sequential manner. Each of these steps could be LabVIEW code or Lab Windows CVI code, ActiveX calling actions. TestStand intuitively differentiates 3 different types of steps. I could have a setup step, a main step, and cleanup steps. So I could put in, let's say I'm putting in the step over here. I could also have the same step and multiple such steps in each of these. The number count here says how many number of steps are there in each of these step groups. So typically we would use setup step group to open references and to start the basis of our program. Main would be where the functionality of our test automation software would execute, and cleanup would be where we would close all our references and abort all running sequences before shutting down the test system. So we have looked at 4 different terminology over here. The terminology we have looked at is sequence file, sequences, step groups, and steps. We also have something known as code modules. So for any particular step, let's say an action step over here, I could call a LabVIEW or Lab Windows CVI or C++ DLL to act and perform certain actions. Now that particular piece of code is called a code module. So let's say I call a LabVIEW code over here for the step action. That LabVIEW code would run every time the step action runs. Apart from this, what I can also do is, instead of calling just another step within the main sequence or any sequence for that matter, I could have a sequence call in which I call a sequence within the same sequence file. So at this point of time, once this starts executing sequentially, at sequence call, the first sequence will begin execution. Once I go inside here, if I have a certain step here, these will execute. Once it finishes this execution, it will come back to main sequence and complete the rest of the cleanup process. So we have discussed steps, which are independent steps which are executed sequentially. These steps are divided into 3 step groups. Each step may or may not call a certain functionality using a code module written in another language. Multiple steps together make up sequences. Sequences are saved in a sequence file, and within the same sequence file, you can have multiple sequences, and when one sequence calls another sequence, it is a subsequence, a very similar functionality as a sub-VI in LabVIEW. So just to revise that, this is the steps pane and the sequence file tab. To the left you have step groups, setup, main, and cleanup, and the sequences pane shows you the multiple sequences that you have on TestStand. Apart from these terminology, there are 4 major components that TestStand contains. One of this being the sequence editor. The sequence editor is where you edit your sequences, which is what we were looking at just now. A user interface is something that a user interacts with. It could look like the sequence editor, or it could be something that you build such that only the functionality that needs to be accessed is accessed. So let's say I am shipping my test automation software to an operator who does not need to know every step of my sequence, then all he needs to do is be able to interact with the user interface. So you have 2 versions of the user interface. One is the editor mode and one is the operator mode, which are shipped by default with TestStand. But this doesn't mean that you cannot create your own user interfaces as and when you like. You can build your own user interfaces from scratch, or you could use the shipped user interfaces with TestStand and modify them. All this runs on something known as the TestStand engine, which serves, which is a server. So the user interfaces and the sequence editors all access TestStand API to contact the TestStand engine, which is installed on your computer. Excuse me. Finally, you've got the TestStand deployment utility, which is used to deploy TestStand sequences and test automation software to multiple computers. So you do not need a TestStand developed system in every computer. A TestStand deployment utility is sufficient. So let me just begin with a new sequence, and in here I'm just going to add, so various steps that you can add over here. These are the various step types that we have. So tests, pass-fail tests, numeric limit tests, multiple numeric limit tests, string value tests. These are tests which give us the results for either in a Boolean indicator for either pass or fail. A numeric limit test also passes the limit test or fails the limit test. So where you have conclusive results, these are numeric limit tests. But sometimes when I'm testing my motherboard, for example, I do not necessarily need to have every step which gives me a pass or fail result. So let's say I just want to power up the board. So then in that case I would use something known as an action step. In an action step I would power up the board and wait for maybe 2 seconds or 3 seconds for the board to power up completely, and then start some processing on it. Similarly, I can make sequence calls, as we have already discussed that, put mathematical statements. Label steps are just like comments in textual programming languages. Message pop-ups are where we pop up messages to the user. Excuse me. I can call executables, load properties, FTP files. I can also use the flow control, which to somebody who's used to text-based programming languages, this will be very familiar. If, else, for each, while, do, while. And I can run different steps of sequences within this sequence. Synchronization is used to lock certain steps of the sequence, or to make sure that certain steps start at the same time and end at the same time. You can also pass notifications, you can queue events, you can make a step wait for a certain amount of time. You can make sure that there is batch synchronization. There are multiple such options available as you go deeper and deeper into TestStand. You can create your own custom steps, you can create your own custom data types. Something that we have not discussed about, which if interested you could read about, would be something known as the process model. The process model is a .seq file, that is a sequence file. As you can see here, the process model that is currently running is sequential model, but you can build your own process models to, so the process model is like the backbone of TestStand sequence files. These sequence files which we create run on this process model, which runs on the TestStand engine. So if you change the way the process model functions, you can change the way each and every customized code of yours which runs on this TestStand test system will function. We have a lot of examples where custom process models are working around test systems everywhere. Finally, one small thing that is a small window that you can see over here. These are locals, parameters, file globals, station globals, very similar to variables in LabVIEW. We can create certain variables here and save values to them. Locals will save values within the same sequence file, within the same sequence, sorry. Parameters will pass values between sequences. File globals are for the sequence file and station globals are for a particular test station. Let me just put in a small example over here and demonstrate a small example. So I have a message pop-up step. The name of the step is step 1. So TestStand is quite syntax intensive, but there's a very nice TestStand syntax helper available. So I'm just going to display hello world with one OK button. After that I will run a pass-fail test. Now I have a VI created for this. So let me just open that VI. Okay, let me just so a default VI which opens up would give you 3, for a pass-fail test, would give you 3 output parameters, a pass-fail flag, a report text, or an error out. A VI which opens up would by default appear like this. Now we're just going to do a little bit of LabVIEW coding, not much. So to keep this simple, I'm going to drop 2 numeric controls. And I'm going to compare them. So if numeric control 1 is greater or equal to numeric control 2, then I will get a true value. I'm just going to wire these controls here so that my TestStand sequence understands that I have 2 more new parameters. And as soon as I open this, it tells me that there's some parameters which are not matching. So if I click on this, now suddenly I have 2 more parameters which I can pass values to. So currently I will not pass them values 0 and 0. I'll pass them values 7 and 5. Let me just execute the main sequence, not the sequence. So I get a message pop-up saying hello world, and the result of the sequence is passed because 7 is greater than 5. This is just a very small example that I am showing you. Of course, TestStand can be used to abstract to much greater levels. So the fail here does not mean that the sequence failed to run, but just that this step has failed. Now, if I create a new local number, which is num1, which is basically a local variable num1, I could store some value in it in a previous step and then pass that value to check whether it is greater than 5. So when I'm passing this locals.num1 value, the value which is stored in this, currently it is 0, but in case in a previous step I have saved a certain value, then that value will get passed on. So it's like a local variable which can be used across multiple steps. So this is just a small demonstration that I wanted to make. Another shipping example that we have with TestStand is a computer motherboard test sequence. You can see this is a much bigger simulated test sequence. I am basically having a motherboard which I am simulating, and I'm telling the computer which parts of it should fail, and it's giving me multiple pass-fail tests. So in a CPU test, I'm calling another sequence CPU test, getting 4 of these pass-fail tests in CPU tests, then running ROM test, RAM test, video test, keyboard test, and if a certain condition is met, then CPU diagnostics is run, which is CPU diagnostics has these 4 pass-fail tests. Let us just quickly run this single pass. So I get to select which test should fail. Let us suppose that I do not select any test to fail. It passes the UUT result and gives me a report, a well-published report. These report formats I can change depending on what is the type of report that I want. I can also change the format of the report. Now you will say, I can do this on LabVIEW maybe with a little bit more effort, but what sort of additional advantage does this give me? So if I run it in a test UUT, which is a functionality of the sequential model, I can, let's say, have UUT 1, 2, 3, in which I say nothing fails. It says the sequence passed. UUT 2, 3, 4, in which a video card fails. The sequence failed. UUT 3, 4, 5, in which the video card doesn't fail, the keyboard fails. UUT 4, 5, 6, in which nothing fails again. UUT 5, 6, 7, in which I want the power to fail. And finally, UUT 6, 7, 8, in which the RAM fails. I get a comprehensive report of all the UUTs that I have tested with what went wrong where, and a well-documented UUT report on it. And this is just a simulated device. I can have this for an actual computer motherboard, and it would not be asking me to tell it what would fail. It would actually be testing using certain LabVIEW code by interacting with the device using the device drivers. So that was what I had to show you in terms of TestStand. So we're going to have a very small contest. The contest of the week is on TestStand. So I just want you to create a TestStand sequence that takes 2 inputs through message pop-ups, saves them to locals. So we have shown you how to access from locals, but how to save to locals is something that you'll have to look at. Message pop-ups, when we configured them, there is a small option to the side which allows you to take in certain inputs. So that is something that you can look at. So take in two inputs through two message pop-ups, save them to two different local variables. That is the first step. Once you are done with this, you can create a small LabVIEW VI that adds two numbers. Make sure that you wire the connector pane. It will ensure that the test stand sequence that calls the LabVIEW VI will allow you to see those parameters. And finally, modify the first test stand sequence to display the result of the addition of the LabVIEW VI and pass if the result is greater than 10. So we will have a final pass-fail test, before which we will display the result of the addition, before which we will actually call the addition. Contest will be live tomorrow morning along with the recording of the session. The winner of the last contest is NI community user Mithun William 770. Congratulations, you will receive a personal message in your NI community profile. The answers have been updated in the Webcast Wednesday session. For extended learning and participation, you can watch the previous episodes of Webcast Wednesday, get your queries from the sessions and LabVIEW resolved, interact with peers and industry experts, participate in weekly contests here and win up to 50% discount in CLAD and other National Instruments certification examinations. You can attend 20 webcast sessions to win a free CLAD attempt. All you need to do is log on to www.labviewenable.in. We now have a small poll for you. So kindly answer the poll with respect to what you would like to watch next week. The recording will be uploaded by tomorrow and the contest of the week too. Thank you very much for attending this week's session of Webcast Wednesday. I hope you did find it interesting that we picked up a new topic on NI TestStand, and we hope to bring you more of the same in the coming weeks to come. See you next week. Thank you very much.